Hello and welcome back to my channel. Students, as you all know, the problem series is going on based on general organic chemistry. We have covered 16 problems and now it is turn of problem number 17. Now let us straight away go and see what is the problem like. Now you can see a compound in front of you on your screen, and as you have now seen that you have two hydrogens under scanner, the hydrogen number A and hydrogen number B, and you have to mind you it's not a benzene ring, so you have to be careful while watching the compound, and you have to tell which hydrogen is more acidic, whether it is A or B. Now again, as we usually do, we will take the hydrogens out one by one. We'll make the conjugate base, that is the carboxylate ion. We'll see the stability of that carboxylate ion. For that we will see that more it is dispersed, more the dispersal of charge happens, higher will be the stability of conjugate base, and then more acidic the hydrogen will be in making these carbene ion, these conjugate bases. Now before we have started taking out the hydrogens, I want to emphasize a very important role which NO2 is going to play. As you all know, the nature of NO2, it can exert a very strong minus M effect and minus I effect, where minus I effect is depending on the distance and minus M is independent of distance, but it depends on the relative position of the NO2 and the corresponding point. Now, and as you all know, mesomeric effect is much stronger than the minus I effect. So we are going to first see the what is the role of NO2. So in this slide I have tried to include the role. After you have elaborated the way NO2 looks like, this is the way it looks like, and as you draw this, you find that there is N double bond O, which is in conjugation with this double bond straight away. So there is a double, single, double. So I have already told you, in such situation, here you can see a carbon is there, here oxygen is there. You have to shift the double bond towards the more powerful oxygen, and as you do that, these pi electrons are going to shift like this, and these pi electrons are going to shift on this oxygen. Once it does that, this oxygen is going to get a minus charge. As you can see in the next resonating structure, a new pi bond has been developed, and this carbon, the electron goes away from, so it will acquire a plus charge. Now this is an end to the resonance. There is another possibility as well. You can see there is a plus charge, single bond, double bond, and you can make further resonating structure like shifting these pi electrons towards this. As it shifts towards this carbon is going to get a plus charge, and a new pi bond will develop like this, as you can see, and plus charge is now coming on this carbon. Now what is the theme behind, what is the motto behind drawing this structure? The thing is very clear. I wanted to show you what is the role of NO2. The role of NO2, since it is in conjugation with the pi system, it can exert its minus M significantly, and it will bring plus charge inside the ring. And if you want anything to be seen properly, you should see the position of the plus charge. You should understand the plus charge is coming just in the neighborhood of this carboxylic group, but once you see the position relative to this carboxylic group, you're afraid it is not coming in the nearest neighborhood. You can see this carbon is not having the plus charge on it because of the minus M effect. Now what is the result of this? What is the outcome of this? That plus charge is coming in the neighborhood of B, it is not coming in the neighborhood of A. What can it do? Basically it will have a great impact on the acidity of A and B. How? Now let us try to understand it like this. I have given two situations. Situation number A, I have taken the hydrogen number A out and again drawn the minus M structures created by NO2 as I drew in the previous slide. You can observe that this is a position from where the minus charge had to be delocalized, because now carboxylate group is created, the minus charge is there on it, and you have to disperse that. But the plus charge is coming, but it is not coming just neighborhood of this group. It is coming next. It is coming next. It is not coming directly near to this carboxylate group. Once you see the departure of A, now we will see the departure of B. Once you depart the hydrogen number B, again a carboxylate group is created, but this time you understand the plus is coming directly in the vicinity of this carboxylate group and will have a huge impact in comparison to with respect to stabilizing this minus charge, with respect to dispersal of this minus charge, and it will start pulling the minus charge to the best extent in this particular structure, as you can see. And therefore you can have a sense that only this is the case where plus was nearest to the carboxylate group, and it could do lots of benefit to that carboxylate by pulling the electrons in the most powerful manner. So now you have understood that taking the hydrogen number B out is giving more beneficial result in comparison to hydrogen number A, because of the stronger effect of NO2, which is minus M. Okay, so from all these discussions you have come to a conclusion that the hydrogen number A is going to be less acidic in comparison to hydrogen number B. Why? Because hydrogen number B removal is taken better care because of the stronger minus M effect of NO2 in comparison to A. And that is how I always keep telling to think very critically the fundamentals behind the question, and you will arrive at some stage, a structure or two, where you can have a proper reasoning, you can have proper platform to answer the question. I hope you must have understood this question. Till then, take a good care of yourself. We'll come up with the questions like these more in future. Thank you very much.